Hi everyone, this is Nafish. Today we are going to get started with images in NumPy. Okay, so I have imported NumPy as NP. You can see here, and then matplotlib.pyplot as PLT. And this is going to be like starting from scratch. Okay, and I will try to explain things very detailed. Okay, so just bear with me. So let's get started. So I have the path of an image right here. Okay, and first of all, we are going to read this image. Okay, this is a picture of a tiger. So you can see I have also imported matplotlib.pyplot as plt. Okay, so the way we can read this image is plt.im, and then if you press tab, you will see these options: image read, image save, and image show. We are going to read this image, right? So I am read. Okay, and then this path I'm just going to copy and paste it right here. Okay, and then quotation mark, the start and end. Okay, so this is the total path, and then you need to have r in front of you so that Python understands this is a path. Okay, so and we do not need this anymore, and I'm going to store this image in a variable called image. Okay, so I'm reading this image and storing it in a variable called image. Okay, so let's run this one, and also now let's visualize this image. Okay, so the way we can do it, plt.im, then press tab, and you see this image show right here. Okay, then parenthesis, then we have our image right here. Okay, so run it, and you can see the image of this tiger. Okay, now one thing, although I'm not going to do it, just showing you, plt.im save. If you have this option right here, then you can save this image. Okay, so we are going to do different operations, right, on an image, and the image is going to change over time. So whenever you want to save the image, you can just do it. You just need to have a name here, okay, of that image, and then whatever you want to save. So for example, if I want to save this image variable image, I'll just save it right here. Okay, so this is how you can save this email, but I'm not going to run it right now. Okay, so let's move into the next thing, which is this image, what is it made of. Okay, what we have inside this image. So the way we can visualize it is image num. Okay, and then let's say numpy. Okay, this is the variable, and then I'm going to convert this image to numpy array. So and then we're going to have the image as input. So image right here. Okay, and then let's look into the values of this variable numpy image. Okay, so run it, and you can see all these numbers right here. Okay, now before we look into the values, just wanted to see the shape of this image. So np dot shape, if we do that, then it's going to give us the dimension of this image. Okay, so here it is. We have 573 rows, 920 columns, and 3 is another dimension, which is the color, okay, of this image. And all the images are made of red, green, blue. So let me write it here. So we have rows, number of rows is 573. Okay, pixels. Okay, pixels are smallest unit. Okay, so what is a pixel? Pixel is the smallest unit in an image. It's made of red, green, blue. Okay, these three colors. So you can see we have in row we have 573 pixels. Okay, and 920 columns. 920 column pixels. Okay, so every one of these pixels are made of this RGB 3 color, and that's why we have 3 here. That's another dimension, which is the color. Okay, also I can write it down right here. Columns equals 920. Okay, and then we have the third dimension, which is the color channels, which is red, green, and blue. This row wise also you can say this is the height of the image. Okay, so the first element, whenever you read the shape of the image, that's the height. Okay, so let me write it down here. This is the height, and this x-axis, or if you look into the column values right here, that's called the width. Okay, that's the width of this image. Okay, and everything we have inside the color combination, this is basically RGB. Okay, which is the all the pixels are made of all these RGB values. Okay, and now we are going to get detail into that. Okay, so this is the shape. If we do np.ndim, this is going to give us the dimension. So have the image as input, and then you can see, as you already know, we have 3 dimension, right? So this is the height, width, and we have the color. Okay, now let's look into one of the pixel values. Okay, the way we can do it, we have the image, and let's say we want to look into 150 row and 500 column. Okay, what are the values of pixel right there? So you can see right here we have 3 values, right? So we have the red value is 182, then the green is 123, and then we have blue, which is 47. As I told before, any pixel is a combination of these RGB values. Okay, and for this specific pixel, these are the values. Okay, another thing, you can see this data type right here, right? UINT, which is unsigned integer, right? Okay, so no negative number. And what is the maximum value it can have? You can just have it this 8 on power of this 2. Okay, and you can see it's going to be 256. So we can have 256 total values starting from 0 to 255. Okay, so this number right here, the max is going to be is 255. Okay, and the mean is 0. Okay, understood? So we can have values from 0 to 255 for this specific data type right here. Okay, and you can see 256. So basically we are starting from 0 to 255, so total 256 we have. Okay, so for this specific value you can see RGB combination, right? You can see, you can just change it, like let's have look into another pixel, let's say pixel at 250, and so this is the height and this is the width. So this is the row number, and this is the column number, right? And let's look into the values here. So 217, 117. So this is a different combination of RGB values. Okay, so what we understand is image is made of red, green, blue values of pixels, right? So let's look into these RGB values separately. So let's say image red is equals to, we have this image, and then we are just looking into the red channels, meaning we are going to have all the rows, all the columns, and then only the red channel. Okay, so let's see how this image looks like. So plt.im show, and then image red. So basically you can see this is excluded green and blue. Okay, so and also you can see like the dimension will be changed. I'll just show the dimension. Okay, so this is no more an RGB, this is only red only. Okay, so let's run it. Okay, so this is how the image looks like. And also let's have this dimension here. So np dot, or maybe you can take the shape. Okay, and then image red right here, and you see this we don't have any color dimension anymore, because this is all the values are red specific. Okay, all the pixels are made of red channels. Okay, that's what it meant. Okay, now we can copy, maybe we can show the blue one to you guys. So let's, so the blue channel is 2. Okay, run it, and this is the blue. So all the pixels here made of the blue values, okay, or blue channel. Okay, and we can have these images all concatenated, meaning like we can just show it side by side. So we have red, and pasting it one more time. So we have red, and then we have green, and we have blue, right here. And then np dot concatenate, concatenate, and then have everything in this parenthesis right here. Okay, and let's save it, image concat. Okay, this is the variable. Okay, so we are going to have all this red, green, and blue portion of the image in a row or in a column. Okay, so just going to show you, let's say axis is equals to 0. Okay, and you run it. I think there should be an error, because I have to have another parenthesis right here. okay, and then run it, and we are all good. Then we can show it. So plt.im show, and then image concatenated, right? So this is row wise concatenation, right? So you have the red, green and blue row wise. You can have it column wise as well. So have it as one, okay, and you have all these images side by side, red, green, blue, okay. And this is, remember, this is only two-dimensional image, okay. So now let's move into like how can we make this image gray, okay. That's another thing. So let's have our original image, which is image right here. I think image numpy, that was, yeah, image numpy, right? So that was our original image right here. So how can we make it gray, okay? So we can just take average of this all three channels. So np dot mean, okay, oops, take mean of this image. So input is our image, okay, and then we're taking mean of this image, and along axis equals to 2, which is like in the color dimension, okay. So we are going to take average of all three color channels and see how it looks like. So plt dot im show, and let's visualize this image, okay. Okay, you see it's not gray, but it should be gray, right? Because we're taking mean of it. The reason it's not gray because I have to say that the color mapping we want is gray, okay. So if you have that, then it's going to show up as gray, okay. Image into gray image in a different way as well. So image gray is equals to so any image we can extract the individual channels, okay. So let's say we have our red channels right here, all the rows, all the columns, and then the first element or first channel, which is red, right? So I'm just going to copy and paste it 2 more times and then change the channels here. So 1 and 2, okay. So we have RGB here, right? Now the way you can make it gray is like there is some weights, multiplying it with some weights. So like 0.299 for this red channel, then 0.587, that's for the green channel, and 0.114 for the blue channel. And this is a like well-defined equation, and these weights are coming from the human, the way we see the gray things, okay. So basically this is, if you just Google search with this RGB gray conversion, you will see these numbers. You know, this is kind of derived from the way we perceive gray, okay. So if we multiply individual visual channels with these factors, we can also get the gray image, and that will look a little bit different compared to the mean, taking the mean of the channels as we did above, okay. So let's visualize this image. So plt.im show, and then we have this gray image gray, and we want to have this color mapping as gray, okay. And this is our gray image, okay. And this is little bit different than what we have here. You can enlarge this picture and compare, okay. Now a couple more things I would like to go over is how can we mask an image. So for example, like we have some important data or something we do not want to show others in an image, so we can do some masking, right? So our original image numpy right here, and let's say I want to mask out one of the eyes of this tiger, okay. So let's say we take so the eye coordinate, if you look into the y, it's from 100 to 200 right here, and in the x-axis maybe 300 to 400, something like this, okay. I'm just guessing. So let's have those coordinates, so 100 to 200 in the height wise, okay. So right here, okay. And for the x-axis or for the weight, let's say 350 maybe to 450, and let's make the values 255. Now 255 is going to be white, okay, because we have RGB all of these colors you know, at full intensity. That's how we are going to get white. But anyways, let's make 255 of all those pixel values and display the image. So plt.im show right here, and then we can have this image numpy. Okay, so we are close. So you see this is a white blend and is kind of covering the eye. Okay, maybe we can, the x-axis, maybe we can start from 320 somewhere there, so that it can cover this other maybe, yeah, this looks good. Okay, so 255 is basically you are having full intensity of RGB. Okay, and if you have no intensity of these three colors, it's going to be black. Okay, so the lowest value 0, that's the black of RGB combination, and the highest value 255 is white. Okay, just need to remember that one. Okay, so you can see we can mask it with this with black as well. Okay, so this is how we can mask it. Now couple more items I would like to share, which is how can we rotate this image. So plt.im show. Okay, and then if you press np dot, I think it's ROT90 right here. Okay, and then slide this input image numpy. Okay, so it's going to rotate it 90 degrees. Okay, so you see we were successfully able to rotate it 90 degrees. Now how about you want to rotate it 180 degrees, right? So the way you can do it, there is a parameter called k right here, and if you make k equals to 2, is going to be 180. K3 is 270, and then K4 is 360. Okay, so this is how you can rotate this image. You can also flip the image. So if I have, let's have the original image first and then do the flipping. Okay, so I'm just erasing this portion right here and then this. Okay, so this is our original image, right? I knew that something will be wrong. So okay, so this is our original image with one of the eyes covered, right? Now we can flip this image, meaning now the left eye is covered, right? So we can flip it and make it look like that the right eye is covered. So np dot flip, I think flip lr, okay, left to right, and then have this image input inside the rounded bracket and run it. So now you can see we were successfully able to flip it from left to right. Okay, you can also do it from you can also flip this image from up to down. So I think it's flip and then UD, up and down. Okay, so if you press that, you see you're also able to flip this image. So hopefully you guys have learned something from this tutorial today. We'll catch up again in next videos. Okay, take care, bye.